In this video, we want to have a look at a very new node in Houdini 18, which is the Pyro source spread. And this is, as I explained, a node that is necessary because the burning of fuel is not existing as a concept anymore in Pyro. So SideFX decided to move this outside of the Pyro system and give it its own node. And that is, I think, a great decision. But a lot of the complexity that is not anymore in Pyro is now in this node. And this node seems like quite simple because it's just one node. It's actually quite complex. And this is why we give it two videos. This video where we explain the concepts, and then we have a look at the preset, which if you type in spread, you get the configure spreading fire. And we will look at this in the next video, but just quickly. The way it works is that it expects, give me a second here, it expects an input like a sphere, for example. And then here there is a box that you can control to an area that is supposed to be hot and then starts burning. So let's increase the size of the, oops, it's a bit too much, of the box here, and let's give the sphere a few more subdivisions. So it looks like this. I mean, I don't think we will do the whole simulation now because it's a bit slow, but yeah, let's look at the outcome of this. And something went wrong. So here, let's go for it one by one. So here you have the what the system does is the sphere gets a couple of points, then an area that is defined in a group where it should be hot, and then in here is where the magic happens. The Pyro source spread then simulates, and you can see that here currently it's let me show the burn, for example. It shows then how this is spreading, and then later in the simulation creates fire in form of the flame volume. So what comes out of this is this volume here, which is just, it's called burn volume in this case. We will talk about this, but this then goes directly into the Pyro server as flame. And this is why you should see when you click on this, hopefully it doesn't take too long, you should see fire and flames go up. So stop this and go to a frame that we calculate. So here. So this is now, it's not, you know, it hasn't risen yet. Let's actually make this a bit faster by lowering the resolution. Maybe we can then see a result a bit quicker. So you can see this now starts to burn. And it seems as if this node is quite simple, the source spread, but it's actually, again, quite complicated because what's going on in here is quite complex. And the bigger problem here is that the presets in this node are kind of confusing if you don't understand what they're doing. So, and actually I saw some tutorials in the internet that explains them wrong because they misunderstand what this node is doing. Anyway, so we will look at this later. I just wanted to show you where this is used, but what we will do is we completely start from scratch and we try to analyze what's going on. So what we will do is because it's much easier to get what's happening, is we take a normal grid and we can give it subdivisions, but it's actually easier to do the way. Another alternative would be what SideFX is doing, which isn't unclever. We just turn this into a bunch of points, because this way we have a lot of points that we can look at, yet we are not limited to some kind of topology. And it's more lightweight because we don't have faces. So this is actually a good idea from SideFX, but you can do the same thing with normal geometry. So maybe let's start with geometry and see how far we can get with this, and maybe if it doesn't work, we can go back to points. So the idea is here that we want to use the Pyro source spread. And as you can see, let's have a quick overview of how this node looks like. We have multiple tabs for different things. For example, temperature change, fuel, and combustion. So the other two, animation and simulation, is not super important. And then we have visualizers. So the idea is that you put into the system, this is something you can see in the configuration preset, you put into the system, actually the absolute minimum you have to add is, I think, temperature. Because fuel is already there, you can visualize fuel and you can see it's red. which means, and this is what I meant, the default is already has already some setting that is easy to overlook. And that is under fuel, there is an injection rate of 1. In other words, here, if I run this, if I return this to 0, sorry, this is how it starts. And if I run this and I'm looking at the visualization of fuel, so this shows me what's happening inside in terms of fuel. And there is already fuel, as you can see. And if I run this, you can see it turns red very quickly. So this is the first thing you have to keep in mind. By default, this thing adds fuel constantly every frame. That's where most people already struggle to understand what this node is doing. Which means all we really need to put into the system is temperature. So let's look how much temperature there is already in the system. We can look at temperature, and you can see it's violet, which means there's nothing. By the way, let's quickly turn off this origin nomen. I don't see it anymore, but it can be very confusing. So when we look at temperature, we can see there is none. And this is something that is the absolute minimum, I think, we have to add. Because I don't, as far as I know, there's no way of adding temperature to the system. So how do we add temperature to this? I think the best approach is using an attribute paint. But there are multiple other ways you can work with groups and all that. It doesn't matter. What you need is just that any point that comes in has an attribute called temperature. And how you do that, it's up to you. So I take the attribute paint, so I change my name of the attribute I'm painting to temperature. And now if I press enter, I can actually paint temperature in the center, let's say. Do it a couple of times and then it should be 1. So if we look at the numbers that we just painted, the highest number is 1. And that's maybe the first thing I haven't mentioned yet. All the data that is calculated internally in this Pyro source spread arranged between 0 and 1, thankfully, because that makes everything simpler, and that's something to keep in mind. So if I put in a temperature of 1, that's basically the hottest the system, well, it's not true, it's not the hottest the system can handle, but it's kind of very hot, it's very high, right? So now let's see what happens if I look through the Pyro spread again and click on temperature, and I have to sometimes click back and forth. You can see on the, well, first of all, let me make sure that the oh yeah. Yeah, the start frame is 1001. This is my setup that starts at 1001. We talked about this before, why that is. Ignore that, it could be 1 as well. Just make sure that your Pyro source spread starts at the same frame. So what you can see is that the temperature is already lower than what we actually painted. And this is because there's already a combustion happened. So already there was something calculated. But let's see what happens when I play this. Okay, it kind of stays the way it is. Let's see, look at the fuel, and you can see the fuel goes up, and then something in the center goes down in the beginning and then goes up again. So very confusing what's happening here. What's happening here, the first thing is to understand, just like in the old system, fuel plus temperature means burn. So fuel is burned by the temperature and creates a burn field. So this is why in the center here we have a red dot. So all of this is a bit weird. So why is the fuel red in the beginning? Why is it getting more, blah, blah, blah? And this is exactly the first problem I have with this node. The settings aren't very logical. So let's do something that makes a bit more sense. We paint fuel and temperature ourselves. So the first thing you should do to make this make more sense is turn off the injection rate. That is very confusing. So now there is no fuel, period. If I run this, you can see there's no fuel added. Nothing is coming out of this node automatically. It only takes what goes in. Let's check the temperature. Okay, there is the temperature. Let's see what happens to the temperature. It disappears. That's weird. But let's talk about this later. This has to do with the fact that there is a cooling rate. So temperature is cooling down. But before we talk about this, let's quickly dial this down just to see what's happening. So all that there is in the system right now is the temperature that we have painted, right? Because we turned off the injection rate in the fuel. So let's see, that means for the temperature, if you visualize the temperature and we run this, it just goes where we painted it and then it slowly goes down. And that is because of the cooling rate. We will talk about this later. Great. Now let's paint on top of this as a second attribute, fuel. And let's switch to fuel. And now we can paint a fuel line. So imagine this is as if I would take petrol and just draw, like, you know, put a line on the ground where where the burning should happen. Okay, so what we have now is fuel and temperature. And those are just attributes on the points of the grid, nothing more. So let's look into our Pyro source spread and look at fuel. There's our fuel, great. And keep in mind, on the first frame, the calculation is already happening. And that's why there's a bit of the fuel gone, because the temperature that we put in has just burned a little bit of the fuel. And guess what? That created burn. Because fuel plus temperature means burn or combustion. So let's see what happens to the let's see what happens to the fuel. It just disappears. That's weird. And the reason for that is that basically there's temperature, there's fuel, the fuel is burned, done. And this creates burn. And here you can see burn is created and then it disappears because it burns away the fuel. And then after a while there is no fuel left, therefore that nothing is burning. So why is this not, and this is the reasonable question to ask, why is this not traveling along the fuel? Because there is nothing that is spreading. It just uses what is there and that's it. And this is why there is another concept called diffusion. And diffusion is basically blurring the whole system. So let's increase the radius of the diffusion. And hopefully, if we're lucky, we should see, yeah, now finally there's a little bit of movement. Basically what we did is the temperature, and I'm actually not, yeah, we can actually show this. With the search radius of the diffusion, we can basically blur the temperature. And the idea is that not just where the temperature is, there's temperature, but it kind of spreads a little bit. It goes outwards. And this is why a little bit of the fuel outside of this blob is affected, and then there is a little bit of a movement. Now at some point there is simply not enough to ignite the fuel. And this is something we can control under combustion with the ignition temperature. So let's turn this to 0.1. So it's easier to burn. So let's see what happens. And now our spreading is longer. And now it's a balancing act. It's still not enough to kind of catch everything. So what we could do is we could increase the surge radius, for example, and lower the cooling rate. And what else can we do? Yeah, something like that. And there you go. So by playing around a little bit, you can get a better burning. So now this was just the first, overview. If that was too fast for you, I understand. Let's quickly visualize this in form of a graph. So one thing we've all learned is, and this is the basic of all of this, fuel plus temperature means it burns and creates a burn field. And then there's total burn, which is interesting. Let's quickly go back because I forgot to mention that. As you can see, when we look at burn, this is where it's currently burning, where there is ignition happening right now. And as you can see, this travels with the kind of eating away of the fuel, and then it stops. But sometimes what you want to know is where there was ever a burning effect, and that is the visualization at the end, the total burn. And this looks like that. This travels with the burn. So this is kind of a memory that tells you, oh, there was a burning area before. At any point. It never disappears. Once this goes up, it never goes down. So if you go back to our overview, this is why I have it as a, on the side, the burn is created, which is, updating itself only where it's currently burning. And then there's a total burn, which is accumulative. So it, adds up. So all of this is more or less easy to understand, but the confusion comes in when we realize that there are so many things that influence each other that it becomes very confusing, because then it looks like this. So those are all the parameters we have in the Pyro spread. that we quickly, some of them we talked about, for example, the ignition temperature. So not every temperature or not every fuel is burning by the temperature. It needs a minimum temperature for it to burn. Then there is the diffusion that makes the temperature blur out to the outside. Then there's a cooling rate that constantly lets the temperature go down. And then some stuff that we haven't talked about is that once the fuel is burning, it actually also creates new temperature. And the other way around as well, or that's true for fuel as well, which is a bit weird. When fuel is burning, we can decide that it's not completely burning off, but it kind of comes back after a while. That's the post-burn rate, which means once you burned it down, it's off, and then slowly it comes back, which is sometimes what you want. And this is then the post-burn rate. Then also, we've always seen that the injection rate, which unfortunately is 1 by default, which I don't think is a good idea, means by default, there's constantly new fuel adding to the system everywhere, actually, which is, in my opinion, the main source of confusion of the system. So you can see it becomes complicated because there's so many things influencing each other, but in its core, it's really just that. So keep that in mind. Those are the kind of the most important elements, and those are the elements that influence those important elements, and then it becomes more reasonable to understand. Okay, so what I do to make this easier to understand, so currently we jump around between fuel, burn, temperature, total burn, diffusion, blah blah blah. We haven't even looked at diffusion yet. This is very nice of side effects that they give us those buttons to make the different attributes visible. But I think it's much better in the beginning to learn about the system by using your own setup that shows all this in next to each other. So that would look like this. So what I did here is just a copy of the output of our Pyro source spread. And instead of using the visualizer, which is connected by those buttons here, I just turn this off. I don't care about this. The visualizer is not what I use, but I actually just use a color node to visualize a certain attribute for different versions, and I spread them apart so that I can visualize different attributes at the same time. And this is way more helpful, in my opinion, to understand what's actually going on. So let's run this example that we just saw. We have, this is temperature that we just put into the system with our paint node. Then we had a fuel line that we added into the system as a fuel attribute. And then here we can see the burn and the diffuse rate, which for, yeah, it doesn't matter. We can talk about this in a second. And now you can see that it's much easier to understand what's going on if you visualize all those attributes at the same time and let it run a couple of times. And this is what I would definitely recommend you to do, because otherwise it can be very confusing to understand the connections. Okay, so this is temperature, fuel, and burn. What we haven't talked about is the diffuse rate or diffusion. Here it's called diffusion, but it's very easy actually to figure out that this is called diffuse rate, because if you middle click, all of those attributes come out of the system, thankfully. So here, as you can see, we find temperature, we find burn, we find total burn, fuel, and that's it. And then diff rate is the only thing that is not named the way we expected. It's not called diffusion, but diffusion rate. So that's fine. And you can already see this is what influenced our system. We just didn't know about it. So if we run this, you can see, maybe here it's better to see, we would actually expect we're looking at the fuel, we would expect this to, let's go on the beginning, to grow, linear. But you can see there is some weirdness happening here. So it's as if there is a little gap where the burning is not happening completely. And this is because of the diffusion rate. And this diffusion rate is a multiplier currently for the temperature, for the blurring, and that influences, and here you can see that very well in the temperature, it influences the way the temperature travels. It makes it a bit noisy, which is nice because it's more realistic, but at the same time, if you want to understand the system, this is not helping. So this is the next thing I would recommend when trying to understand the system. Again, the first thing was turn down the injection rate of fuel, very confusing. And second, turn off the diffusion rate noise, which is on by default. So let's turn this off and now rewind. And you can see there is no diffusion happening anymore. And we should see that in the way the temperature now behaves. If we look here, and we can see, yeah, that's a clear line now. There's no complexity happening anymore. It's just straight burning it down, and this is exactly what we wanted. So this was the reason why it behaved so weirdly before. The third element that we haven't talked about yet, which is diffuse rate. So, and this is why it's so complicated. All those things influence each other. And again, if we look back at this, what we just looked at was the diffusion here, this guy, who blurs the temperature while this is happening. And so by influencing a temperature, you influence the ignition temperature. By this, you influence the combustion, and therefore even the burn will result in a noisy kind of result. Okay. So what can we do now? I mean, maybe we already covered everything we need. You should definitely play around with this. But let's go back to the fuel. Fuel again has an injection rate. So yeah, let's start with fuel. Let's add the injection rate a little bit to see what happens. And here you can already see in the fuel there's something has changed, and that is it goes up. So the burning, on top of the fuel that we bring in, the system now adds a little bit of fuel on top everywhere. And this is not everywhere though, because it has a noise on top to make it a bit more interesting. And this is why now if you turn this up, everything is burning, because now there's fuel everywhere. This might be what you want if you want a wide field of spreading fire, but if you don't want that, this is exactly what you have to turn off, and this is what we did in the beginning. If you want that, again, the control you need to make this more interesting is the noise underneath. So if I turn this off, this is just everywhere the fuel, but the noise multiplies what you give it by noise, of course. So let's say we increase the element size, and we can also make this a bit more contrasty so that we have holes basically. Actually, let's go back to this. Yeah, maybe. So we have big gaps where there is no fuel anymore. And then here you can see now the behavior is quite different, and the burn looks quite interesting. So what else is there in fuel? Yeah, let's turn this back to 0. This is injection rate, which means that's what's constantly coming in. What you also can do is you can give it an initial fuel, which again uses the noise. And this means here is fuel, but it's only there in the beginning. So if you run this, you can see it's burning away, but it behaves quite differently, because this time it's not constantly adding more to this system. But once it's burned off, it's gone. Let me quickly, yeah. Once it's burned off, and this is why the behavior is quite different, which can be exactly what you want. So it's important to understand that. And then there's post-burn rate, and that is a bit confusing, because let's turn both to 0, and let's go back to our line here that we drawn. The post-burn rate is quite interesting, because it means once it's burned away, it stays burned away for a short amount of time, and then it comes back to life, which is quite interesting. That looks like that. So it burns away, and then, where is it? Maybe I have to add it higher. Yeah, here it is. And here you can see now it comes back to life. Maybe I have to find a good number where it's not too fast and not too slow. Yeah, let's say 0.7, something like that. So you can see it's gone, and then it comes back. So it's a little bit as if the fuel leaves a little bit of fuel behind, but it's not actually accurate, because this disappears and then comes back. So even if it then burns again, it will come back later. So the explanation of the parameter is after a point has burned, it will then inject fuel at this rate, scaled by the injection noise in 1/24th of a second, which means, again, it's an injection. It's not just leftovers, but oh, here was something that was once burned. Let's now over time inject in this area again, which is an interesting one, but it can be, of course, very confusing. But here you have it. It will never completely go away. Wherever there was fuel before, there will be a little bit of an injection happening over time. Okay, a similar thing to this you will find under combustion, and that is burn rate and temperature output and burn output. So this is what we talked about, what we've seen here. So combustion not only creates new fuel with a post-burn rate, if I turn it on, it can also create temperature from the combustion. And this is what we will find here under temperature output. So let's let's move this to 4. I wonder if we can actually see that. So here temperature. So when it burns, yeah, here you can see it. It just creates more temperature, which in turn is, if there is still some fuel, will let this fuel burn again, which in turn it creates more temperature again. So if I dial this down, it's still happening, and this can actually influence your burning. If there's not enough temperature created, then it's hard to ignite stuff around it. Yeah, okay, I mean, I think I'll leave it at that. I don't want to overcomplicate things. Then the burn rate means how much of the burning fuel will actually turn into burn. So this basically means, as you can see here, this is where our burning is happening. Okay, fair enough. So let's increase the burn rate to 1. You can't see a difference. So let's decrease it to 0.1. Yeah, and here you can see now there is basically the burning is slower. That's a way to look at it. And that's actually how it's described. It's how much fuel is consumed in a certain amount of time. So if you lower this, the combustion is still happening, but the burn rate says how slow or quick that is happening. So you can see everything slows down. So this is a speed control, basically. And of course, what we see up here is the ignition temperature. So this says at which temperature it is actually burning, and then how quickly it is burning with a burn rate. So let's turn this back to 0.5. And then before we play around with this, the last one, because it's very simple, it's a burn output. This is simply when it's burning, what kind of number comes out of it. So if you put it to 0.7, then anything that burns will create the number 0.7 in the burn value. If you put it to 6, then the number that is here, you can actually check that under burn, will be 6. That's all. It's just the multiplier of the end result. It's quite simple to understand the burn output. Okay, and then the ignition temperature, let's play around with this. I wanted to show you, if you turn this to 0, then what happens here, let's run this. You can see that the fuel basically instantly burns away because it doesn't need any temperature to burn. Even 0 means it burns away. So that's why it's set to something. And 0.2, as you can see, is a bit, well, depends how you set it up, can be a bit too low. Personally, I wouldn't set the ignition temperature too low. Usually when you need to do that, you want something else to change. So for example, more temperature output and more diffusion is usually what you want. And then the cooling rate, yeah, maybe this one, if we dial this up, and I think a lot of people on the internet agree that the cooling rate is set a bit too high. You can see that it instantly burns off if you put this too high. So that's actually a good tip. Dial it down, because then it's a bit more expected behavior, what's going on here. So let's lower the ignition temperature. That might help to not cool it too much, but yeah. So two things, the ignition temperature is important in combination with the cooling rate, of course, just like we saw, because the cooling rate lowers the temperature, and if it's too low, there's no ignition, and therefore those kind of things are kind of connected to each other. Okay, I think we're almost through. Is there anything I forgot? No, I think that's pretty good. So yeah, yeah, I think we've seen a lot. So in the I don't want to play around with this yet. I will. There will be an example soon where we actually use that. For now, I just wanted to give you a very simple concept that is not too hard to understand, so that we understand better later when we use something more complex. Because later it will be more complex, because we can then choose what kind of those information we will actually use for what we want. So I will not use this in this video. This is more like a very theoretical analysis of what this node is actually doing, so that we can then make better decisions later on. Okay, I think I'll leave it at that. In the next video, we will look at the configuration that uses that by default, the Pyro configure. What was it called? The Pyro configure spreading fire, to understand what is happening here in this particular example. And then hopefully we'll see that this is kind of one very specific case that is not covering the whole complexity of this node. And this is why I wanted to start with this more theoretical analysis. Okay, see you next video. See you then.